Right, hello. Welcome everyone that is joining. We have several people registered for today, so we'll give everyone a few minutes to join and then we'll get started. All right, I have two afters, so we're going to go ahead and get started. And welcome to the first session of Energy Modeling Deciphered for Architects virtual workshop presented by AI Virginia's Committee on the Environment. Today, we'll be discussing great design, climate, daylighting, and comfort. My name is Delaney Ogden, Director of Education for AI Virginia, and I'll be the host helping with presenting the webinar today. Few housekeeping slides before we get started. We will have the chat feature available to you, so please feel free to engage with that chat feature. Maybe drop a note of where you're located, what you do, introduce yourself. That would be great. We will have a short Q&A portion after the presentation for you to engage with our speakers. So please feel free to use that Q&A tool to put your questions out there, and we'll do that towards the end. If you have any connection challenges, please remain on Zoom. Zoom is really great about trying to reconnect you. So just give it a moment if you deal with any connection challenges today. Also, for optimum bandwidth, it's great if you have all of your apps in the backgrounds closed. That will definitely help with any connections. And then we will be sending out a survey after the session today. We'd love for you to hear your feedback, what you thought, any advice on going forward. So please take some time to complete that feedback. Next is the slide about LUs. Today the session's pending for one AIA LU, and the credits will be reported within 10 business days. And as I mentioned before, we'll have a short Q&A period after the presentation. These are our speakers and moderator today. So I would like to now turn it over to Amy Upton, and she will do a great introduction of our lovely speakers. So Amy, turn it over to you.
Thank you, Delaney. Hi, everyone. Thanks for joining us today. I'm really excited about this panel. These three speakers are really amazing and so knowledgeable. So I just wanted to give a little bit of introduction. It's a little out of order from the photos, but I'll start with Kevin Flynn. He's an architect, a lead fellow, a national sustainability practice leader at Mead & Hunt, which is a large integrated practice firm that's been doing architecture, engineering, construction, sustainability, and more for over a century and counting. After we go through some introductions, Kevin's going to kick us off with setting the stage for this panel series of sessions, and also talking about what we need to know about integrated modeling and component modeling. Mickey Chapa is an architect, a lead AP, Living Futures Associate, a certified passive house consultant, and building scientist at Payette. He's also part of their building science group, and in addition to energy modeling, he focuses on even more on life cycle assessments, daylighting, material health, and circular economy. And Ajit Nayak is a vice president and director of building performance analytics at Bowman Consulting, which is another large national AE firm. He is a licensed professional engineer with a mechanical focus and a FIAS certified verifier, and is a building energy modeling professional. And he's been a lead contributor to the ASHRAE BEMP study guide. So all three are great presenters. They all teach at universities, which means we're in for a treat because these experts in energy modeling are very well versed in holistic sustainable design with a focus on carbon reductions, and they're great educators. I was hoping that each of them could just, expand on their perspective and fill in any gaps in what I tried to summarize about their experience, and maybe even focus on what their perspective for today's discussion will be. And Ajit, do you want to start with that?
Yeah, that sounds great. Thank you for the introduction, Amy. Can you guys hear me okay? Great. All right. Yeah, so thank you for the invitation. I'm Ajit Naik with Bauman Consulting, as you mentioned. Bauman Consulting is a national firm. We're not actually a design firm. We are architects and engineers, but we're focused on sustainability consulting, building simulation, commissioning, and kind of energy services as well. So I have a background as a mechanical engineer. I worked as an HVAC designer for several years, but throughout my career, I've been working with energy modeling, CFD, daylight analysis, and other different kinds of building simulation. So for the last, close to a decade or so, I've worked as a commissioning agent, making sure that, the things that we learn from simulation actually make it into the design and get built and tested the way they were modeled. So I'm really excited to talk with you all today.
Great, thanks. Mickey, do you want to fill in any gaps?
Sure. Thanks, Amy. Thanks, Ajit. Yeah, so my background, I began as an architect. So prior to my role here, worked for 10 years at different size companies, a large A&E, and then a small growing firm in Norfolk. So, always good to be back with AIA Virginia. Yeah, but, from my trajectory through the architecture practice into a building science degree, and now being able to focus on it full time, started with a lead, started with the small things, started with any opportunity that we could get to influence design and influence environmental features on the projects, and then going now being able to work on all sorts of analyses and build on past successes, build on smaller little investigations, and then layer those into a project, and what that means. So we'll touch on that a little bit today, but yeah, great to be here again.
Thanks, Mickey. Kevin, do you want to go next?
Absolutely, thank you. And just a point of clarification, I am not currently teaching at a university, though I have taught before, but I'm not currently doing that. I am an architect and a designer. I've been in the industry for over 40 years. That's 40. It's a long time. And well over 30 of those it's been an acute focus of mine for sustainability and energy efficiency. I've worked internationally. I've worked at big firms. I've worked at small firms. I've had my own firm as an architect and a consultant. And now I'm back working with Mead and Hunt. Looking forward to today's presentation and helping and learning a little bit from everybody here today.
Great, thanks. And do you want to start sharing your slides?
I will do. Yes,
great,
thank you.
thanks.
And I really preferred the old technology, where I would just start speaking and images would appear in your minds as I did that. So, but now we're going to use a little PowerPoint deck. So I'll do that now. Can you all see that?
Not yet.
Not yet. Let me. Well, this is why I prefer dual technology.
All right, now we can see your screen, but
now you can see.
We got it. Yep.
Thank you. All right. I think this is information that's probably not new to anyone, but I think it's important to set the stage and remind ourselves of why what we do matters. The impacts of buildings on our planet and on our resources. Buildings are responsible for 40% total end-use energy consumption, 29% in the US, 74% of electricity consumption, 14% of water. We emit 39% through our buildings. 39% of the greenhouse gas emissions on our planet can be directly attributed to our buildings, and 11% of global embodied carbon and 75% of global life cycle carbon of our buildings. Those are big numbers, and so it's in our best interest and our responsibility to try and improve those numbers and it's a race to zero. We're trying to get there. Part of how we can get there is to early in design, and I mean from the very beginning of thinking about design, really beginning to look to find ways to reduce our energy consumption, our fossil fuel use, our water use, and still provide beneficial places for people to live and work. The important part is to start early, to use a framework. For those of you who don't have one, we really want to work as an integrative, interdisciplinary team. Using the AIA framework for design excellence is a great starting point. It at least helps frame discussions around all of these issues. We also want to establish a baseline energy use intensity for our buildings. So we have a goal and then set goals to reduce against that baseline, and working across disciplines, measuring our performance, and never letting the minimum become the maximum to which we aspire. Design starts early. Even in site analyses, we're making decisions that impact our energy use. Views, understanding the site is important, where winds come from, the soils, the vegetation, hydrology, solar exposure, future weather patterns, of course, are important, because right now when we model our buildings, we often are using outdated climate data from 20 or 30 years ago. And we know that climate is changing, and that the climate will be very different in 40 years and 60 years. We've been seeing this happening already, and at rates unprecedented. So I encourage everyone to start thinking about what's going to happen in the future rather than what has already happened in the past. Mickey, if you'd like to chime in.
I can jump in here. So this is a tool that was actually developed at University of Maryland's climate program. And just to give you an idea of like the relative importance of evaluating, the right weather file or the right climate for your building, what it means now and what it's going to mean in the future. So I think we could share a link to this so you can play around and just see what this means maybe in the different areas or climates that you work. But yeah, so we're seeing here that the climate of Virginia may start to look more like Texas, more like Louisiana. And what does that mean for our assemblies? What does that mean for our building systems? If we're designing our projects for 50, 60, 100-year lifespans, that is the influences on those buildings are going to change in that period. So it's And this is another tool, just to gain some familiarity, depending on where we all come from in our background with energy modeling. If you're starting from scratch, as Kevin mentioned, one of the things that we begin with is just looking at a climate file. So this is one tool for just looking at the data that comes along inside of a climate file. So it's this CBE climate tool. And you can look at different wind analyses, psychrometric charts from all over the country, all over the world even. And this is available for free. We'll talk a little bit about some tools and things that are around for everyone to use, but this is a great way just to get in and, start to look at what's going on in the environment, immediate environment around your project site.
We start every project by doing an intense site analysis. As we chatted about earlier on the previous slide, we really want to understand the site, and critical for everyone, especially if you are used to working in the same climate zone. You can begin to understand the parameters of that site and how it's changing, and what's going on locally. And that's the most important condition that we want to look at, is what's really happening within that microclimate of each climate zone and city and place. We also do a lot of significant risk analysis around climate change, because, as we said, the site we have today will not be the same site in 40 years. It's going to get warmer and hotter. It might, there might be other risks, such as utility grids failing, movement of people and population, and how that impacts our design. But we believe that everything must start from the site and help impact our design decisions there. And it's really important to get started modeling early, and that means at concept or programming or even budgeting, and being heavier in design during concept design and schematic design, very front-end loading, so that we can use energy modeling as a design tool rather than just a prescriptive way to check the box. And then, Mickey, I know you've suggested that it continues to happen during design development and construction documents, and even into construction administration. If you want to share a few words there, otherwise I'll move on.
So part of our exploration and use of these tools are that we have the most impact at the beginning of the project, but then there are some certain check-in points that are required. Say if you're doing a lead energy model where you need to be demonstrating some improvements during schematic design or at the end of design development, and have a report and documentation along the way. And then through construction documents and CA, you may be using it for verification or for confirmation to various interest groups of cities, permitting, any other reasons. So.
Wouldn't mind, Kevin, if I just chime in. I would say there's actually energy modeling not only can be used during design and construction, but it's even useful post occupancy. So you can kind of have a model that calibrates to your building and kind of run what if scenarios so that you can better inform your maintenance, your operations, and your retrofits. So it's truly a tool for the whole life cycle.
That's a very good point. Thank you. And in fact, it's very important to know, because often what we do in design can be greatly impacted by the operational sequences and use of the building. We'll explore that a little bit later, but almost no building operates exactly as the predictive energy model might show. And if we have an understanding of what the actual operation of the building is and the energy use intensity is post occupancy, that helps us to either go in and take some corrective measures to improve that performance, or to help us design in the future when we have a better understanding of how buildings are being operated. Again, we've seen this early on. We have the design decisions we make have the greatest impact at the lowest cost. And as we move through the progression of the project schedule, that reverses and changes. And so our ability to impact cost and performance is very important to know that that's done early, and the cost is the least. And as it moves through, our ability to impact cost and performance decreases significantly, and any choice we make then becomes more expensive generally.
Yeah, and I'll add that ASHRAE actually puts out a standard 209 that describes like kind of how you should be energy modeling throughout the life cycle. I dropped a handy little image of it in the chat, but those interested should check out the standard itself.
Perfect. Mickey.
Sure. Yeah, and so this is just a little thought about like how the energy modeling process works and compares to the design process, right? So we have validation models where we might use like the full building to document for lead credits or for permitting, but there may be, you know, better design impacts that we can do by looking at smaller, you know, smaller studies, like whether it's just facade or at a specific atrium or, you know, an entrance moment or something that you want to look at, and then you can refine from there. So there's a different level of entry that you can go about looking at these. So if we get the next slide. And yeah, so then the previous two, you know, the architects maybe say we're traditionally in charge of the, you know, the building as a whole and the direction that it's going, but we may not always have, you know, visibility into the specific systems. So what you'll see here is like if you've done an energy model before, say with like Cove Tool or with Sapphira, or, you know, you've gone in and, you know, picked a system. So whether it's like all air or some, you know, VRF or some other type of system, but there is opportunity for conversation kind of like within this, that and that's the level that, you know, you start to have conversations with, say, with an energy model, with your engineer, with your design team. And there's a really interesting space when you can start to look at subcomponents of this and how they influence your design. So, you know, like any good design prompt, like where there are, you know, where there are limits, that's an opportunity for us to get creative, and then also, you know, work with larger and larger teams.
One of the components of design that have a great impact on the performance of the building is the massing and orientation, of course. And sometimes we don't get to choose that; they're locked in. If we're doing an addition to a building on a tight site, there's only a little bit of room. You know, we get what we get, but we try to make the best of what we can get. And so when we begin doing that during design, though, we can explore different paths and really do comparative energy modeling. And, you know, what's the energy use intensity predicted to be if I'm all my glass is facing south or west, or it's a 3-story building rather than a 1-story building. Exploring different massing models and very early shoebox energy modeling, simple box modeling, make it become a design tool rather than something that we just check afterwards, so that we actually while we're exploring massing and the design elements and features, that we can also be exploring how that it impacts our energy use intensity. Because we can spin this buildings, you know, 57 different ways. We only get to build it once, you know, unless we're building a mess of Target stores all over the nation. But generally, we're doing one-offs, right? And so we get to explore all the crazy little things we might want to do, and then understand how daylighting is affected, how the shadows fall across other properties, how the building can shade itself sometimes. And nearly every decision we make impacts energy use and performance at least a little bit. And it's in our best interest to understand what those big moves are versus what the little moves are. You can understand here by, you know, on this bottom part, we're arranging the building in many different ways, and the range of energy use intensity doesn't vary that much from option to option, from a 43 up to a 46. But you begin to understand what moves drive energy use intensity, and these are just passive things we're doing. We haven't even talked about building systems yet, or amount of water or air that we're using. It's really just looking at glazing and transparency, all of the passive things in the envelope, insulation, you know, how much redundancy we're having in our systems. Those things have great impact on our design of buildings. So I encourage everybody to, you know, look at passive strategies first, and reducing load through those means before we start trying to power those loads with mechanical systems. And know that single strategies don't work. It's really like the connection of all of the strategies we're choosing that begin to have the most important impact on our design. We can't rely on just a mechanical system. We can't rely on just glass. It's got to be everything.
Yeah, and another, one of the really interesting things too, just from the architect's perspective, is that when you're able to input this into your design process, you do begin to realize that these all decisions you are making are also spatial, right? So each of the design moves that you're taking, they may have positives and negatives associated with them, depending on the season, depending on your program. And then being able to look at those like in greater and greater detail, start to, make, begin to generate questions that can influence your design and, get people excited about the project, just not even from a environmental perspective. There's some other thoughts on here on this slide too about, are you looking at, say, the annual energy usage, across the all 12 months, or are you just looking at peaks? So is there, by looking at different time scales of the data, are you able to, say, reduce energy size and reduce upfront costs and the associations of, embodied carbon and other complexities that go along with that?
Oh, if I
I
could
think critical to what we're doing, at least what we're trying to implement at Meet Nunt, is to make it fundamental to our design process rather than having it be something extra that gets done and a line item that can get crossed off by an owner when you're talking about scope. We really want it to be inherent and fundamental to our design process, so that it just becomes sort of our de facto way of operating and designing. And when we get through all of the explorations, then we can, we're never quite done. There's always something else that we need to focus on, and then we can begin optimizing the building on the site, and really begin studying how it's behaving on this site, in this town, in this microclimate, in this climate zone, and really optimizing solutions for the building itself. Again, now this, a couple of these images are from Cove Tool, which we use a lot because we like it. It can do very simple things very early for us, and we generally get within 5% of the more detailed energy analysis that might take weeks and weeks and weeks, and we can do it in a few hours and multiple times for our project. So we like that we get the majority of the decisions made early, and we understand pretty much how it's going to operate. And then when we want further validation, we can do the more intense design and detailed energy modeling on building performance.
Kevin, if you wouldn't mind, that's a great point. I using it as a design tool just to give people like an anecdote on what that might actually look like. We were the energy modeler for the Brock Environmental Center in Virginia Beach. Some of you may be familiar with it. It's a net zero building. And a lot of the decisions that you're talking about that have to be made early are things like how thick are the walls? Like, how thick is the roof? It's very difficult to make structural redesigns and redesign programs to account for thicker walls or heavier roofs, like, anywhere outside of the very earliest part of the design. So, that project had a goal from the outset to be net zero, produce more energy via on-site renewables that it consumes. And so the question we started asking is like, how do these things trade off against photovoltaics, right? So that building has got triple pane, the good German windows, right? And it was a lot. It was actually, at the time I'm looking at it at the 2012 dollars, it was 26,235 extra, right, to put in the triple pane windows. But with the energy model, we were able to say, that's the equivalent to make that much with photovoltaics. You need 25 photovoltaic panels, right? And that was actually, at the time, $32,000. So it was actually cheaper to put in triple pane windows. You already have to buy the windows. It's 26 extra. Why not do that instead of buy more photovoltaics? They've got R50 roof. It was the same thing there. It was actually twice as expensive to provide the same amount of PV as it was to go from an R30 to an R50 roof. So these are kind of the questions you can ask, like, how do these things trade off, against other cost centers in my design?
Yeah, I think that comparative cost analysis and life cycle cost analysis is really important, because you're describing doing passive things first to reduce the load, before we worry about how we power them. And one of those options is using on-site renewables. Well, if we can reduce our energy load significantly enough, not only do our mechanical systems need to work less, and maybe we can use less of them, but we need to buy fewer and fewer on-site renewable energy components as well. And in the quest to get to net zero, that's important because cost is always an issue. I've never had a project where there wasn't a budget, and where there wasn't a significant gnashing of teeth over how those dollars are spent, and having to convince folks what's the right choice.
There might even be some tearing of hair and beating of
There
chest.
might be, I've done a lot of it myself. So it's good to know. Thank you for sharing that.
Sure. And just to speak to this, the graphic that we're looking at here, like, as you know, depending on your particular program, the more you do it, the more familiar you get. And then, over time, you can begin to work down and really dial in on the strategies that are appropriate, the ones that are cost effective. So, every time you do an energy model, you're learning something new. And then over a period of projects and years, then you can really start to implement and influence your practice.
Yeah. We were talking about energy use intensity, and that's the measure. If you haven't heard that term before, it's the amount of energy a building uses in kBTU hours per square foot per year. So you simply take the total energy use of the building, divide by your square footage, and you get what your energy use intensity is. Ways that we can benchmark what it should be for a building is we're doing this, if we're trying to meet the AIA 2030 commitment challenge of getting to zero by 2030, and the amount of reductions we need to do to get there. They're using as their baseline the 2003 commercial building energy survey, the 2003 CBEX database. You can find those benchmarks within Zero Tool, which is a free tool. Just please type it in, zerotool.org. You can go in and use this tool, and by inputting some very basic information about your building on the site, they will give you what the baseline is and what the target number would be to meet the 2030 challenge. You can also do that in the AIA 2030 DDX, the Digital Data Exchange platform. If you've already signed on to the AIA 2030 commitment and challenge, that tool is free to use. That gets us into the same place. It gives us our baseline energy EUI, our target EUI, and then it shows all sorts of other data along with that. And through the COAT super spreadsheet calculator in their resources section, they give us the same information. So there's other places, Energy Star, and all sorts of other places to go and find what energy baselines are. And it's at least something to compare our performance against, and knowing, wow, my energy model shows that I'm using 237 kBTU per square foot per year, and I should only be using 98. So there's probably something going on, right? And if we don't have goals to reduce, there's nothing to measure ourselves against. So it's important to pick goals and then work towards reducing that energy amount. Ajit, did you have something to say?
Yeah, just another tool I just popped into the chat there is the Energy Star Target Finder. So if you get energy model results from a consultant or somebody internally, just punch those numbers right in there, and you can see whether it's realistic. Like, am I actually planning a building that's better than 100% nationwide?
Yeah,
right. It's a good way of setting an expectation.
Yes. Energy, here's just a list of a few best practices, because we know that not everybody is going to have access to some of the energy modeling software early on within a building design and project. And if you can't incorporate it into your firm, as you begin to work on projects, maybe with an outside energy consultant, you're going to be learning things on every project and begin to understand what things make big differences to you, especially if you work in the same building types and in a similar climate zone. for much of your practice and work. Things that we've learned that are passive things to do that are really best practices. One, focus on the orientation and of the glazing and utilize daylighting, harvesting, and sun shading, and understand how those things work combined in system. Try to limit the amount of glass you're using. All glass buildings can be really, really sexy, super fun, beautiful sculptural elements, but they're terrible energy performance most of the time. And so if we can use a window to wall area ratio between 30 and 40%, generally that's going to be better. Eliminating thermal breaks, using continuous insulation. The more insulation we can push to the exterior of the skin, the better it's going to be. And if it can be continuous, it increases our R value, and it increases the performance of the stated R value in a wall assembly. And then using a continuous weather barrier to increase air tightness and making sure gaps are sealed. These are all passive things that just go into contributing to improved energy performance. Lowering your lighting power density. The code does a great job of making us go a little bit further. If we're designing to the most current code, which is the ASHRAE 90.1, well, it's reference. ASHRAE is not a code, but it's a standard. But most codes are referencing either the IECC 2021 code, which is similar to the ASHRAE 90.1 2019. And some states are already adopting and designing towards future codes. We're going to be probably 30 to 40% better than the 2030 CBEX database just out of the gate, just by designing to code. So that's an important thing to know. Just, try to do better. Don't let the code minimums stop you from doing more. But if that's all you can do, then that's all you can do. And you're already going to be doing better than the benchmark standards generally. And then by doing comparative and iterative energy modeling early during the design process, when you can, please do. It helps you reducing plug loads. Look at Energy Star equipment for efficiencies. Make all your buildings solar ready, so that if we can't afford to put solar panels on our buildings and rooftops initially, at least we can do so later when more money becomes available. And then really, as getting to the point that that Ajit made earlier, is look at how the buildings are performing after occupancy and commission those buildings during design, during construction, but then also if you can check in later with your owner and do some continuous commissioning and updates, sort of like going to the dentist every year to get your teeth cleaned, right? That's what we do. We could do that for our buildings too, and then always keep building on our performance. Just looking at a few things that have impact in terms of systems on our building. After we've designed our buildings for interconnected systems, mostly, even if it's not intentional, that's what we're doing. The areas of greatest impact, air tightness and glazing area, and glazing U values and factors on the front end, big impacts. Roof insulation, other things part of the building envelope, the solar heat gain ratios and the glazing, HVAC systems. And then the biggest one of all is occupant behavior and how the buildings are being operated. Because we can design a building to operate at a certain percentage of savings, and it can be operated in a very different way. And so they may not be operated to the levels that we had planned for. But that's going to, and if we can get utility information on an ongoing basis after occupancy, then we get to learn about how the building's being operated and maybe make some suggestions to the owner about that.
If anybody's been to Reagan, when it's backed up in a crowd, what it's like when a building is operated how it wasn't intended, and it's unpleasant.
Right. Yes. Yeah. And then, also part of energy modeling is really beginning to look at how now we can begin to model different parts and components of the building. So how the structure behaves and what pressure that's putting on our systems. Moisture and humidity. I've talked about this a lot, but optimizing the envelope's really pretty critical and important in our energy use. And daylighting generally seems to be a starting point to the discussion. Not only does it improve occupant health and behavior and views and indoor environmental quality, but it also impacts energy use. And we use less if we've got more ambient daylight that doesn't and not all of the heat gain that comes with it. We use less of our building cooling systems. We can use less lighting. We have better health and impact, and it's an entry way and gateway into talking about sustainability and other things that we can do to impact performance and design.
Right. So then, as you get more and more comfortable with, say, a given analysis, then you can start looking at the other competing demands, right? So if we're looking at daylighting and views, and maybe there's other things that we need to consider, right? It's like, is it a big window? Are you in a cold climate? Is there a downdraft near the window? What is the relationship between daylighting, energy, and then comfort inside the building for different occupants? So I mean, this is another tool. It's hosted by Payette on our website, and you can use it to compare different glazing assemblies. So again, there are a growing number of free and open source tools to facilitate these discussions with your clients, and even internally with your design decisions that you're making.
And we have a listing of some of those tools a little bit later in the presentation. Here's just a very very simple example of what we can do. This is a small regional airport in Merced, California. These images came out of SketchUp and Cove Tool. So this is during concept phase, where we probably had 15 or 16 different options that we were looking at. We had the top 3 faves, of course, and we're only looking at 2 here. And this was done during concept design, where we hadn't picked the structural system yet. We kind of knew what it might be. We hadn't picked any building systems yet. We kind of knew what they might be, but we designed, and we showed this according to what the code minimum requirements would be in terms of a building system. And from Cove Tool and or Zero Tool, we would have found that the 2030 baseline was an EUI of 91. And just by designing to code, our EUI was a predicted 64.77. Just call it 65, right? So that's a 29% reduction in energy use just by meeting the code. A competing option, concept 2, slightly different EUI, a 66, pretty darn close to the 65, and that's a 28% reduction. Okay, and then as we progressed during design, still during concept, moving closer towards schematic design, we narrowed it down to just a couple, getting a little bit more information, seeing where the major energy use was. And in an airport, the equipment's one of the major energy expenditures. With any passenger boarding bridges or TSA checkpoints and baggage handling, equipment's always a big user. But we were able to further reduce, change our mechanical system from a constant volume to a VAV system with an air source heat pump and some package DX cooling. We were able to reduce that from 51% reduction from the 2030 benchline and 31% reduction from code on concept 1, and 49 and 30% reductions on concept 2. Well, we moved through schematic design, continuing to do more modeling and more development, and we ended up, with a system total that was a 46% reduction over the baseline. So not quite 50 there. We had to make some changes, but this was based on a slightly different mechanical system with a direct outside air system, still with an air source heat pump and a packaged direct expansion. Sorry, go back. And then we are also studying what we might do in terms of daylighting and glare. So here's our preliminary daylighting analysis on the left, And on the right, taking that daylighting and understanding where there might be too much annual solar exposure and too much glare. So anything that's green is good. Anything that's yellow is we're getting a little iffy, and anything red and black is there's just too much glare in those spaces on an annual exposure. So it tells us that we might want to do some more shading or have some controls to eliminate that and improve passenger comfort. Also, on every project, we like to do at least a gap analysis in terms of how to get to zero. Whatever our energy use is, can that be powered on site by PV or some other form of on-site renewables? And so we look at where we have the best solar exposure, where, what size system could we put there, what impact would it have on the building, and whether or not we can actually afford it, and look at the life cycle cost analysis of that. And so we do this for every project, whether the project can afford it or not, in terms of putting on-site renewables, just so that we have the information moving forward as we try to make our buildings solar ready.
Right, and then this is just a little example of like once you have embedded these analyses into your practice, then you can scale up with the other tools that are available, whether they're generative design tools, and Autodesk has a suite that is available to plug in. So we saw some shadow analysis early. Maybe these could also be optimized and leveraged against your environmental data that you're starting to pull in. So again, like the more then you can begin to kind of elevate your practice over time.
I know we are probably running short on time. We still have a little bit of content to get through. I think.
Yeah.
Go ahead.
Sorry, Kevin. Yeah, maybe we could just like flip through this last couple quickly, but this is just an example of our kind of process over time. You're working your way down, and then tracking. So keep tabs on your projects. The 2030 commitment is a great way to force that in your office every year. If you haven't signed already, definitely encourage everyone to have that conversation. Right, but then you can start to look at adding on different softwares to your design practice, and we can speak to some of these. These are a suite that we use. Kevin, you mentioned Cove Tool earlier. My office definitely leverages the Honeybee and Ladybug as plugins for Rhino. So if that's something that's within your practice, that can be an easy and a free way to really dive deep into different explorations.
Yeah. There's a lot of tools. Many of them are free. Use them and use the proper tool for the proper analyses. Here's a listing of some of the free and open source tools. In terms of energy modeling, there's Energy Plus and Open Studio, the DO2, Honeybee. There's a free WUFI analysis to look at wall assemblies and where dew point might occur within those assemblies. That's important to understand. Climate Consultant and the CBE Climate Tool, of course. Daylighting, Honeybee, Light Stanza, Climate Studio are all great tools. And then the assembly analysis through Therm and Window 8.0. I have not personally used the Opaque 3.0 beta, but Mickey has, and he's got it listed here.
Yeah, that's a simple one for looking at different wall assemblies, where different stud configurations and exterior materials based on a limited little collection of standard building materials, and that help you get a U value. And one of the maybe we can move from here into the questions now, but
yeah,
is what are the data points that you need to have conversations, right? So Kevin and I are architects, Ajit is energy modeler, commissioning agent. So what are the pieces, right? Is like, do we need to have the U value figured out or optimized in a smaller analysis, and then we can feed that into our whole building energy model and see what that does, and then start to plug in and test different variables, or glazing size, or any number of other variables.
Thanks, guys. It's so much great information, and I know it's a lot for to whirlwind, and people probably have even more questions. But in the interest of time, I'm gonna just start sharing some of these questions that have come up. Reed asked, and maybe Mickey, you could start with this. At what threshold does energy modeling become the domain of the specialist consultant and not something that most firms can perform in-house? And is a threshold defined by software or by special training or something else, or all of those? And as an architect, I mean, starting this in-house versus handing it off. What are your thoughts?
Sure. I mean, so it definitely depends on your client and your program, right? So if it's a single family residential, at what scale are you going to be able to do an energy model for that? Is the client willing to support that or experiment? So some are, some might not be. And then like whether or not, like what are the points that you could say to influence that conversation? I mean, I'm using like probably like the most challenging one, because if it's a lead project, you're going to go out and get that energy model as part of the team and bake it into your project, right? So on the larger scale projects, that's something that you can start to add team members, add consultants, add scope and fee to accommodate these things, and whether that's done in-house or out of house, you can decide. But when you get down to the smaller level, the smaller scale, then you have to be smarter with how it's done. Whether you're kind of having a conversation about, okay, hey, do we want to go after a passive house? Is that the right thing for this project, or is it, like what are the other things that you can do to influence your client to kind of pursue that? And in some cases, maybe you're just doing a simple shoebox model, right? So you're going out and learning a couple tools to, do a SketchUp model of the envelope or something, like very, very simple, just to model in the windows and model in the major envelope components, and then, testing that on either some simpler software that's out there, or so. I don't know, is that helpful?
Yeah, no,
Kevin,
that's
Ajit, any thoughts?
I would just add one thing to that, right? Like definitely when you get further on down the line, you need a specialist. It's detailed. But there's really just one, in my opinion, is one simple thing on whether or not you should be doing energy modeling. So if you do a simple energy model, are you able to tell like whether the results are reasonable? Right. And that is really like the do or don't. Like if you're gonna get results and it looks like moon language to you, then it's a sign that you shouldn't be doing this, right? But if you run a model and you're like, wait, that looks like a pretty high energy user for an office in Washington, DC, based on my experience with those buildings used, then yes, that's a sign that you're ready to do, some early phase energy.
Great. Okay. We have a couple other questions in Q&A, but before I go to those, I know that Charles Mata raised their hand probably a while ago. So Charles, I don't know if you want to unmute and ask your questions since you've been patiently waiting. Oh, we can't hear you. Maybe you could type it into the, oh, okay, it was by accident. Okay, well then moving on. There's a question about, well, Ian asked, what is required to make your building solar ready? And I know, Kevin, you showed a slide and talked a little bit about it, but Ajit, maybe you could just explain a little bit about solar ready design?
Yeah, I mean, you need space to put the panels, and you need a path to send the conduit, and you need space to put a panel in the electrical room, and you need to have a plan how you're going to connect to the grid, right? Like those are really the basic elements of being solar ready.
Yeah, and when depending on the size of the system, we may need to be doing something different with the structure, the roof assembly, and how we connect into that, and so make sure that the structure is sized for those panels to carry that weight. Quite often, it's already done by default, but still something to look at. And if it's going to have impact any wind uplift forces, especially if they're ventilated panels on stands and not directly secured to the roof, then it might introduce some other concerns relative to design of the roof system and structure.
Great.
And Kevin, you mentioned earlier to electrify, right? So that you're
Yes.
making use
Yes.
of that power once you're
Right.
generating it
Yeah.
on site. Yeah.
Yes.
Yeah.
Yeah.
Good point. Kevin, I think this question came up when you had that slide up which showed the bar chart with all the different areas like HVAC and occupants. And the question is, like, what tool did you use to get the impact of each building feature on the vulnerability opportunity scale?
That was done in Open Studio and Energy Plus. You can get part of the way there in Cove Tool and other tools as well, but that particular information came out of an Energy Plus program.
You can, it's called the sensitivity analysis. You can do it with any software. It's just asking what if questions. It's not just for design. You can be like, what if it's really hot next year? What is my energy use? Like, it's just, you look for a low end and a high end, and you kind of see how resilient your design is to these kind of future shocks.
Yeah, that's great. There's a few other questions, but one question is also just, are these slides going to be available? And I didn't know if Delaney or William, like, if there's any housekeeping you need to do at the end of this before we get shut down at 1 o'clock. I assume the slides would be available and or the recording.
Yes, Amy, that's right. We can make the recording available for everyone and the slides, and we can send out an email to let them know where that'll be.
Great. And there are 2 more sessions. So if your question hasn't been answered yet, perhaps you need to register and join in one of the 2 subsequent sessions coming up that are also free. And maybe our panelists, if there's a question that we haven't had a chance to answer, if you could type an answer, that if you have time for that, that'd be great.
Do we have time for one last question while we're still here?
Yeah, William, do we have time for one more?
We absolutely do. Take it away.
Okay, great. All right. There's a couple specific questions, but this one's a little more general. This one person said, intrigued by the notion of doing like a net zero ready analysis for every project. Do you get internal pushback? What's the client feedback like? How much time does this take, and how much detail do you provide? I think that's a good question that probably a lot of architects are thinking about.
Yeah, as we do it for every project on a preliminary basis, it takes 4 hours. And we don't even ask our client if they want to pay for that, because it's just part of our work. Now, if we decide, hey, it looks like, this would make a lot of sense, then it's a discussion with the client and to determine, do we want to do more detailed analysis and life cycle assessment, and that becomes a little bit bigger deal. But generally, it might only represent another 30 hours of work to get that done. So if it can be incorporated into our existing scope, we always do it that way. If it requires a little more add service, then it's a conversation we have with the client.
For those who, may not have the budget and accountant with the sharp pencil, an easy way to do it. It's just like, what kind of energy, what's the maximum amount of energy that you can use if you only have space for photovoltaics on the roof? Is honestly, like, the steel structure that it takes to put in photovoltaics over a parking lot is like crazy expensive and always gets beat out. So realistically, like, it's a good question. Like, how low does my energy have to be, to just be covered by the space I have on the roof for photovoltaics? Is that a reasonable target? Are other buildings of my type in the area achieving that? Like, would I have to be 75th percentile, 50th percentile, 25th percentile? So even without doing any energy modeling, you can kind of say, here's what here's my limit. Here's how much better I have to be than the average pack to get there.
Okay, great. Thank you, everyone. A little bit of introduction. My name is William Abrahamson. I'm the co-chair of the AA Virginia COAT Committee on the Environment. If you're enjoying today's material, please come back and register. There's a link in the chat for the next 2 sessions. You have to register for each session individually. The next two sessions are intended to be workshops. We'll be diving deeper into what the process of making an energy model is. We'll have some examples about the sensitivity analysis that was mentioned, some of these questions about the software tools. We'll go into a little more detail on that. So definitely sign up for those. The goal of this series is to give you a working understanding of the tools at hand, so you can raise the dialogue internally, whatever your professional capacity is, to get this into your design process. Again, also, if you appreciate this contact, if you enjoy the dialogue, sign up for the AA Committee on the Environment. Get involved with the committee. You can help. We have monthly meetings where you can share knowledge and ask questions and network, and you can help set the agenda for the next year ahead. So I think that with that, that's all we have. Delaney, am I forgetting anything?
Nope, that is everything. Thank you so much, William, and thank you to everyone who participated today. And we hope to see you at the next two sessions.
Register. Thank you all.
Yes. All right. Have a great day, everyone. Thank you. Bye-bye.
Thank you, guys.
Yeah, thank you all.